So what we're going to start with on this particular project is something like this, sort of, kind of, minus the structure part, and we'll talk about that why later. We'll talk about why later. But it's kind of funny. I was doing some Googling just for structural package diagrams, and this one came up, which is a good friend of mine from school. It was during our thesis year. So this is actually from my thesis class, but it communicates exactly what we're going to approach in order to start understanding structural algorithms. So to give you just like the 2-minute primer of structural megastructures like skyscraper systems, generally speaking, there are primary vertical elements, which are elevators and exit stairs, and then structural members like giant columns or trusses. Those are usually bound together by some kind of truss system or structural frame. In this case, it's a belt truss, and that's what you see in that diagram in the middle up top. And then from that, the floors are built, right? So imagine that belt truss or whatever type of frame is tying this thing together. Imagine that that's the ground, and you could either build up from it, or imagine that it's like a giant space frame in the sky, and you can hang things down from it. So that's generally speaking the way that skyscrapers are engineered. Okay, 2-minute primer. We spent an entire semester doing this kind of stuff. So it's not really that simple, but for our purposes, just trying to understand massing and a little bit about making it a believable idea, that's generally what we need to know. So what we're going to develop is a series of masses, and we're not really going to delineate right now between elevator and stair and everything like that. We're just going to have a central core. We're going to understand what it's like to develop many floors in a Grasshopper mass, and then we're going to start to study how we might develop skin from that. That's all for the first week here, I think. So I'm going to introduce the floors and the mass on the outside here today, and then next week we're going to look at breaking things down into a little bit more detail to give us something to work with later on when we get to facades. Okay? What questions do you have about that before I continue? None?
Are you recording?
Yes, okay. I am recording. Thank you. All right. So back here, we're going to get into Grasshopper. That's weird. Huh? Yeah, I think he set it up so that you're gonna have to do that every time now if you sit at a different seat. So I don't know. Anyway, so we've got Grasshopper open. The way that I'm going to establish this is I'm gonna build it off of a base floor or footprint. And then I'm going to develop it in Grasshopper from then on. Or actually, you know what? I think I'm going to simulate it with two. So I'm going to go into the top view, and I'm going to build a rectangle. And I'll put it out in space there, and I'm just going to make it 80 feet by 120 feet. Okay, something like that. And I'm going to go into perspective, and I'm going to make a copy of this. Let's see, 80 by 120. Let's just go 200 feet up. $200 feet. What's up? Okay, so what I'm going to, sorry?
What's the height?
200 feet. Yeah. So what I'm going to do with this is I'm just going to simulate the actual massing part for now. We'll actually develop real masses later, but I'm going to drop in these curve references, and I'm going to set that to be that curve, and then I'm going to set this one to be that curve, and I'm going to rename these appropriately. I'll just call this top and bottom, I guess. Sorry, am I blocking you? That's a poor seat to sit in for this kind of class. But all right, so we've got top and bottom. You guys know now how to make a simple mass, right, with this, or at least just the skin part. That's really all we need. So I'm going to go to Surface, Freeform, and Ruled Surface, and I'm just going to take top, and I'm going to connect it to bottom, and that's where I get this. Now you're going to notice some odd corners and stuff. If you're concerned about those corners, you can kind of fix that. I think that's because these curves are poly curves right now. If you want to try and fix that, I think you just need to explode them. So I explode them, and then you can set multiple curves, and you should be able to get them to work like that.
So exploded curves.
Okay, so anytime, I'll also say this, guys, on the subject of those curves, or the edges being like really oddly rounded or truncated, as long as the actual edges that you see are correct, generally the geometry will be correct, okay? So if I went back and I re-referenced that and I baked it, it would still bake out correct. It's just a graphic issue that Grasshopper sometimes has with poly curves, polylines, yeah, stuff like that, okay? Or really complex geometry. So anyway, I mentioned that we're going to have a structural core. The good thing about structural cores is that that is going to be something that you can generally just build in Rhino. As long as your core is simple enough, you can just put a mass in Rhino and never have to touch it again. But, well, yeah, anyway. So I'm just going to do that. I'll go into the top view here. I'm just going to put a core somewhere in the middle. It's really not critical, so that should be fine. And then you'll want to extrude that curve, make sure solid equals yes, and extrude it 200 feet up. What's that? No, it doesn't really matter. Just make it something like that proportionally.
200 feet?
Mm-hmm. Okay. So here's the idea, guys. What we want to make is a set of floors that are going to match the building. You guys get that so far, right? Like the floors are going to just shoot up inside of this tower for now. How do you think we could do that? Just roll through the process that you would take to get there.
Deconstruct.
What's that?
Set list?
What?
Set list? List line?
No.
Can you
You're
deconstruct that geometry?
You're sort of. You're kind of on the right track with deconstruct. The idea is to get a surface, right, and then use that surface and array it, right. If you were doing it in Rhino, you would use array, right, to create like 50 floors, right. But because Grasshopper creates multiple geometry in every command because it is algorithmic, it doesn't have an array function. So we're going to do it with using move, and the only thing that we have to change is how many numbers we plug in to move, because if we move it 0 and we move it 1 and we move it 2 in the same command, we've made 3 copies of that geometry. Does that make sense? All right. Are you guys ready to go? Because I hear chatter. A fair bit of chatter. Question?
Yes.
What?
Mine is hollow.
Select it and type in cap.
Cap.
Okay, let's get going. So the floor is actually really easy. That's going to be my bottom curves, and I should be able to just create a surface with this. Oh, that's right, because it's no longer a poly curve. Let's do it with surface freeform, and boundary surface. So the difference here is that a polycurve can go straight into being a surface, but a set of 4 curves that aren't a polycurve or aren't tied together won't. So anyway, this is the floor, right? And the floor is just going to be moved, and it's a z function, so we don't have to worry too much about that. So I'm going to go to transform, Euclidean, and move. And I'll plug this in. Oops. Plug the geometry in, and what you see is it moves a little bit. Okay? So it moved 10 feet in the z direction. That was the default. In order to make this array, all we have to do is create a panel or create a list of numbers. And let's say we wanted, I'll just do 0 and 10 and 20 as an example and turn that off of multi-line data. Oh, we need a z, sorry. Vector, vector, unit z. Plug that in like this and you get 3, right? So it's the same thing as array. Now, what we want to do is make this a little bit smarter though. So I think what I'm going to do instead of the panel, which I'll have to change manually every time, is I'm going to go to set sequence, and I'm going to create a series of numbers. And this part's pretty easy. It just says first number in the series, the size for each number, or what your step count is. So like how far is the next number going to be from the old one, and then how many of them do you need. So what I'm going to do is set up a bunch of panels. So my first one is going to be 0, and then the step count, or the step number, is going to be how many feet I want from floor to floor. So I'll copy and paste that, and generally speaking, commercial structures will be anywhere from, at a minimum, 12 feet to 15 feet in some cases for a typical floor-to-floor height. So let's just pick, let's do 14 feet. Make it an odd-ish number. Well, I mean an even number, but you know what I mean. Okay, and then how many do we need? So well, there isn't really a rule of thumb because you can engineer anything. But let's say that each of our floors are going to be, let's just go with 8. I think we'll do 8 floors per. Well, actually, yeah, let's do 10. 10 floors, plug that in here, and we get a list of numbers, and then I'm going to plug that in there, and that's what we get. Okay, so turn everything else off, and what you see is a set of floors for your structure. The part's super easy so far, right? Okay, so then when we want to make the floors have thickness, we just extrude them down. So I'm going to go to Surface, Freeform, Extrude, and I'm going to take each of these floors, and I'm going to do Unit Z again. Actually, I'll just copy that. Copy, paste, disconnect this. And I'll just put a panel in there for -1. And now they have thickness. Probably the easiest thing you've done in weeks, right? Yeah, it is. Okay, well, here's the part that's not easy. I have this volume here, right? Well, what happens if I go to my design critique, or my review, and the critic says, let's make this more interesting, it needs to twist, right? The problem is, I'm going to select this thing, I'm going to rotate it so that it twists a little bit, and it's going to do that, but then my floors don't match anymore. Okay, so what we're going to do is make this so that it's a totally smart system, and it will automatically adjust with the changes that we make in the volume. Okay? Questions before I shut this down? Okay.